Okay, now for the next portion, we will be looking into parallel and perpendicular lines. And we have at our foundation, okay, we have the point-slope equation, whereupon we have y minus y1 is equal to the slope m times the quantity of x minus x01, which leads up to the slope-intercept equation, which we have at y is equal to mx plus b. Now for parallel and perpendicular lines, now we have for parallel lines are going to be distinct lines, in other words different lines, that will have the exact same slope. And instances of what we have for sets of parallel lines, we have in the first case we have y is equal to 4x plus 3 and y is equal to 4x minus 2. Now both of these equations are written in slope-intercept form. And again, in the slope-intercept form, the x-term coefficient is going to be the slope. So in both of these cases, all right, we have the equations with the same slope, in this case, which is going to be 4, and the lines represented by these equations will be thus parallel. And we have likewise, for the second set, we have parallel lines. We have with these, in the second set, we're going to have the x-term coefficients to both be at -2/7, and again the equations are also expressed in slope-intercept form, and since we had the same slope, those lines representing these equations are also going to run parallel. Now for what we have regarding perpendicular lines, and now since parallel lines head out in the same direction, since they are distinct from each other, they are never going to intersect. Now in the case perpendicular lines, okay, we're going to have another story. Now for perpendicular lines, now instead of having the same slope, perpendicular lines are going to have slopes whose values will have an opposite sign reciprocal relation. And another way of wording this is that the product of the slope values will be -1. And in terms of how the perpendicular lines behave, now where parallel lines will not intersect, perpendicular lines, on the other hand, are going to meet or cross each other at a 90-degree angle. And we have, just for examples of perpendicular lines, okay, we have, first case, we have y is equal to 4x plus 3, and we have y is equal to -1/4 of x minus 2. So you have the presentation of both equations in slope-intercept form, and we have for the first line we have a slope of 4, second line we have -1/4, and if I multiply the slope values together, the product is -1, so the lines are going to be perpendicular to each other. Now in the second case, we have the first line is going to have a slope of -2/7. Now for the second line we have 7/2, and if I multiply these together, again we have an opposite sign reciprocal relation, and the product of the slope values will be at -1, and that is the indicator that the lines representing these equations are going to run perpendicular to each other. Now, and let's say that in looking at the determination of the equation of parallel and perpendicular lines, and let's say, for instance, okay, on the side of looking at the equation of a line that is going to run parallel, and we have in this example, okay, say we have a line that is defined by the equation 2x plus y is equal to 5, and we're looking at the line that's going to run parallel, where the parallel is going to also run through -2/7. Now first of all, we need to find out just what the slopes are going to be. Now for the given line we have 2x plus y is equal to 5, and if I determine what the slope value is going to be, I need to rewrite this equation in terms of the slope-intercept form. So we have for 2x plus y equal to 5, if I get the y term by itself, I can deduct 2x from both sides, and so we're going to have here, upon isolating y, we have that y is equal to -2x plus 5. And from the slope-intercept form, we have with the given line, okay, so you have the slope m is equal to -2. Now for the parallel line, again, a parallel line is going to have the same slope. So we have for this we have m is equal to -2. And again, so we have with parallel lines, again, these are going to have the same slope. And now regarding the parallel line, okay, so we already have established that the slope value is going to be at -2. And going through -2, 7. Okay, so we're going to set up with the point slope equation of a line, whereupon the x1, y1 values are going to be respectively at -2 and 7. So for the point slope equation setup, so have y minus y1 is equal to the slope m times the quantity of x minus x1, and we have, upon substituting, we have for y minus y1, we have y minus 7, and we have for the slope m, we have at -2, and we have times the quantity of x minus -2, and we have with the point slope equation, we have y minus 7 is equal to -2 times the quantity of x plus 2, and then we have, in creating the pathway to the determination of the slope-intercept equation, we have, upon distributing -2 over the quantity of x plus 2, we will have -2x minus 4, and we have, upon getting the y term by itself, if I add 7, so it's going to turn out that y is equal to -2x plus 3. All right, and so looking at what we have here, now y is at 7, x is at -2, left-hand side of the equation is at 7, and we've got -2 times -2 is 4 plus 3, which is also at 7. So -2, 7 belongs, and again, the slope is at -2. And in terms of the graphs, for both 2x plus y is equal to 5 and y equals -2x plus 3, again, you're going to have these lines are going to run parallel to each other and will never come into contact. Now, in the case of what we have with perpendicular lines, say if we have determining the equation of the line that runs perpendicular to 2x plus y is equal to 5 and that runs through -2, 7. So we're working with the same given line once again. So for the same reason, okay, we have the slope, again, is going to be at -2. Now, in establishing what we have for the perpendicular line, again, perpendicular lines will have an opposite sign reciprocal slope. So in looking at what we have now, so the given line, we have a slope of -2. And again, the opposite sign reciprocal of -2 is going to be a positive 1/2. So again, we have with the product of the slopes, so you have m of 1 times m of 2 is equal to -2 times 1/2, and that is going to be equal to -1. And again, just utilizing the same point, perpendicular line is going to run through x1, y1 is equal to -2, 7. And setting up what we have, utilizing the point slope equation algorithm. So we have, once again, for y minus y01, we have y minus 7. For the slope m, okay, this time we have positive 1/2. And we have times the quantity of x minus -2. And we have in the rewrites, we have y minus 7 is equal to 1/2 times the quantity of x plus 2. So this setup is the point slope equation. And if I take what I have and create the pathway to what is going to be the slope intercept equation, so we have y minus 7 is equal to 1/2 of x, and 1/2 distributed over positive 2 becomes positive 1. And in looking at isolating what we have here in y, so we have, upon adding 7 to both ends, okay, so you're going to have that y is equal to 1/2 of x plus 8. And so that would be the equation in this case, and you can go back and check. Y is at 7, so left-hand side of the equation is at 7, and with x at -2, 1/2 times -2 is -1 plus 8, and we had the right-hand side of the equation to also be at 7. And just as an illustration for what we have for the lines that run perpendicular. So again, we have, reapplying, we have the graph of 2x plus y is equal to 5, and that line again is going to be sloping downward. But we have for y is equal to 1/2 of x plus 8, we had the graph to be sloping upward, and we have the lines are going to intersect at a 90-degree angle. And again, we have for the perpendicular line, again, this again runs through the point -2, 7.